Finally, we have arrived at the our last lesson of the unit 4.9. We are going to be solving linear and quadratic inequalities algebraically. Okay. So last lesson we solved it by graphing. Today we are going to be solving it algebraically, which I think will be much easier. Well, depends on what kind of learner you are, of course, right? But I think to me algebra is easier. Okay, so just to remind you again, once again, inequality sign will change if you multiply it or divide it by a negative number. Okay, so keep that in mind. All right, so here is our first example. We are going to solve these two linear inequalities, and this time we're not going to show the answer as a number line. We're going to show it in interval notation. Hopefully you remember that from last year, Math 10. If you don't, that's okay. I'll show you again. Okay. So when we solve linear inequalities, really it's just like solving linear equations. You're isolating for x. Okay, so now in this case, I'm going to minus 9x, so I get negative 5.6x plus 8.8 plus 8.8 less than, this is 11.2. Now I can divide both sides by negative 5.6. And you should get, now notice we're dividing by negative number, right? Negative number, so we now need to flip the sign, so it's x is greater than negative 2. Okay, so negative 11.2 divided by negative 5.6 is negative 2. Now this is the solution. This is shown as a just the inequality sign. Now it's asking us to show the answer in a interval notation. So it says x is greater than negative 2. So if you recall, last year, there were interval notation is basically you're writing an interval of numbers. Okay, so this x bigger than negative 2 is telling us the smallest value of x is negative 2. And there is no biggest value. So what that means is it could be it's going to be bigger than negative 2, and it's going to go all the way to infinity. Okay, so what we do is we write negative 2, and that's the smallest value, and we're going to write positive. Oh, that's an ugly looking infinity. We're going to write an infinity symbol to represent that it just goes to a very, very big number, and there's no end to it. Okay, now if you recall, there were two kind of brackets that we need to use for interval notations. There is the square bracket. There is also the regular bracket. The square bracket indicates that it includes that value. Okay? The regular bracket means it does not include that value. So you can see here it says x is greater than negative 2. So there's no equal sign here. So this tells us that it does not include negative 2. So we need to use the regular bracket. And for infinity, you will never use square bracket. You cannot include infinity because infinity means it just keeps on going forever. So you can't contain that, right? So in this case, this is the solution. Okay, it goes from negative 2 to positive infinity and not including either of them. Okay, so again, the square bracket represents including that value. Regular bracket does not include that value. Okay. All right, I'll show you one more example for part B. We now have some fractions. I think some of you may have seen this. What we need to do is multiply every single term by the common denominator. Okay, and the common denominator in this case for 3, 4, and 2 is 12. So you go 2x over 3 times 12. You can divide both numbers by 3. That's okay, this is 12 over 1, right? So that's 1, and that's 4. So 4 times 2 is 8x, plus 1 times 12 is simply 12. Bigger than equal to 3 over 4. Again, you can divide this by 4, so that's 1. This then would be a 3. 3 times 3 is 9x. Half of 12, that one we don't need to really multiply. You can think about that. Half of 12 is 6, so minus 6. Okay, so now we can solve for this inequalities. I'm going to move everything, all the x's to the left. So minus 9x, I have negative x. That's positive 12, so minus 12, bigger than equal to negative 18. Now we need to divide it by negative 1. So again, we're dividing by negative 1. So we need to flip the sign. X is less than positive 18. Sorry, x is less than or equal to positive 18. So now this time it's x less than or equal to 18, so that means 18 is the biggest value. We don't have a smallest value, so this means we are going to go all the way to negative infinity. And as I just mentioned in the previous example, we never include infinity, so that would be a regular bracket. For 18, however, because there's an equal sign here, so this is going to be a square bracket, and this is the solution in the interval notation. Okay, it goes from negative infinity to positive 18, including 18. Okay, so that's how you solve linear inequalities. Is basically you solve it like how you would like linear equations, except it's with inequality sign. Again, this is what you need to keep in mind. If you're multiplying or dividing by a negative number, you need to flip the inequality sign. Okay, quadratic inequalities is actually quite similar. What you need to do first is factor, find the x-intercepts. Okay, so here is the equation, here's the inequality. Just like quadratic equations, when you solve quadratic inequalities, you must make sure that one side is 0. Okay, so you can see this is 0 here, right? This is already set up for us. That's perfect. You need to make sure one side is 0. Okay, so once you have this, you just need to factor this. This is x plus 4 times x plus 1, and that's greater than 0. Okay, so now what you need to do now is, well, we have two x-intercepts. In this case, this is negative 4. In this case, x is negative 1. Right? And now what I'm gonna do right now is I'm gonna draw a number line here, and I'm gonna put negative 4 right here, and here's negative 1. So what we need to do now is we need to test points. Okay, so I'm gonna call this region 1, this is region 2, this is region 3. And I need to plug in some numbers within those regions into this inequality, and then see if it makes sense or not. Okay, so for region 1, I'm going to pick, so I need to pick a number less than negative 4, so I'm just going to pick negative 5. For region 2, I need to pick a value that is between negative 4 and negative 1. I'm just going to pick negative 2, it doesn't really matter. Okay, any numbers. For region 3, I need to pick a number that's bigger than negative 1. 0 is always nice to use. Okay, so for my region 1, I'm going to plug in negative 5 into x and see what I get. You don't actually need to calculate. Okay, well, you do, but you do and you don't. Okay, so because we're comparing against 0, so really what you need to do is you need to figure out if this is positive or negative. So this is negative 5 plus 4, which is negative number. Negative 5 plus 1 is another negative number. We have negative times negative. This is positive. So this makes sense. Okay, so I'm going to put a check mark beside number 1. Okay, now I'm going to check numbers for in region number 2, which is negative 2. So that's negative 2 plus 4 times negative 2 plus 1. Okay, is this bigger than 0? Well, negative 2 plus 4 is positive. Negative 2 plus 1 is negative. I have positive times negative. It is definitely not bigger than 0. So this does not work. Okay, it does not make sense because this is actually less than 0. Okay, I'm going to say this is less than 0. Okay, so it doesn't work. And we try the numbers that we picked for region 3. So that's 0. We have 0 plus 4 times 0 plus 1. 0 plus 4 is positive. 0 plus 1 is positive. Both are positive, multiplied together is going to be positive. So bigger than 0. So check. So what this is telling us is that region 1 and region 3 are the answers. Okay, so now we need to somehow come up with the interval notation for this. Okay, first of all, I notice there's no equal sign in the inequality, so I know my answer will not be including negative 4 and or negative 1. But because in region 1 we are looking at on the left hand side of negative 4, so it's from negative infinity to negative 4. So region 1 really is from negative infinity, that's as small as it gets, all the way to negative 4, again not including negative 4, and you will never include infinity, so you need to use regular brackets. And from negative 1, again not including negative 1 because there's no equal sign here, all the way to positive infinity. Again, it's to the right of negative 1, so it keeps going to the right, so it's getting bigger and bigger. There's no end to it, so it's infinity. And this is the solution for this inequality. It goes from negative infinity to negative 4 because it's in this region, and that's to the left of negative 4, so it goes to all the way to negative infinity. And also region 3, it works. You can see I put check marks there, and that's to the right of negative 1. So negative 1 is the smallest value. It goes all the way to as big as you can imagine. So that's infinity, and again, you do not include either of those, so you put regular brackets around negative 1 and infinity. Okay, so that's how you do that one. I will let you try part B. So again, this is quadratics, so what you need to do is you need to make sure one side is 0 and go from there. Okay, so I'll let you try it and I'll come back and show you the solution. Alright, so I made it one side as a 0, factor it, and I have my two x-intercepts here. And then I drew this intervals, and I'm picking, again, I have, this breaks into 3 regions, and I've picked 3 numbers to test each interval, each region. And when I plug in negative 4, it's bigger than 0. That doesn't work because we want it to be less than or equal to 0. In region 2, I plug in 0, it does work. In region 3, I plug in 2, it does not work. So this part is my solution. So I'm looking at between negative 7 over 2 to positive 1. This time it does include both negative 7 over 2 and positive 1 because you have an equal sign here. Okay, so your solution in the interval notation would be from the smallest value, which is negative 7 over 2, all the way to the biggest value, which is positive 1, and you will include both of them because, again, of this equal sign right here. And that's why this time you need to use square brackets. Okay, so that's how you solve inequalities, linear inequalities, and quadratic inequalities with algebra. Okay. Hopefully this wasn't too difficult for you, okay, because we are gonna look at some more problems. All right, let's see. It says the height in meters of a projective. Okay, that's a typo, it's a projectile. Okay, from the top of the building is given by h of t is equal to negative 2t squared plus 9t plus 54, where t represents the time in seconds. The projectile is in the air. How long does the projectile take to hit the ground? So hopefully this one is not too difficult for you. This is not actually in this lesson. This one we are actually looking at equation, right? Because we want the height to be 0. So part A, 0 is equal to negative 2t squared plus 9t plus 54. Okay, and now you need to solve for t. Is this factorable? Actually, I don't know. 108, let me see. 3, 4, 6 and 18, no, 7, 8. Okay, I don't think it's factorable. Okay, so I guess we will need to use quadratic formula. Okay, so that's okay. So t would equal to negative b plus minus b squared minus 4ac divided by 2a. And now you need to plug this into calculator. This is negative 9 plus minus, that's 81 plus, I don't know, 8 times 54 for 32, yes, divided by negative 4. This is going to be negative 9 plus minus plus 81. This is 513 divided by negative 4. Okay, so now I know I need to abandon the negative 9 plus, because when I do that, I know square root of 513 is bigger than 9. So if I do negative 9 plus something bigger than 9, that will turn into a positive number, and positive divided by negative 4 is going to be a negative number. Time cannot be negative. So I know right away I need to reject that answer. So then really my answer is negative 9 minus root 513 over negative 4. And now I'm just going to put this into a calculator and see what I get. Okay, so negative 9 minus the square root of delete minus square root of 513, and then divided by -4. So that's 7.9 seconds. So it takes 7.9 seconds for this projectile to hit the ground, okay? Part B, what is the time interval that the projectile is above 60 meters? So now, here is the question. Because we are looking at the height above 60, so we want height to be at least 60. Therefore, well, it's not an equation anymore. We'll end up with an inequality, -2t squared plus 9t plus 54. We want this to be above 60, so we don't actually include 60 as well. So above 60 means bigger than 60. Okay, not including 60. We want it above 60. Okay, so now we can solve this. Again, just like quadratic equation, what you need to do first is you need to make sure one side is 0. So you move 60 to the left, -6, bigger than 0. 12, not factorable, okay, so that's okay. So then we just need to use quadratic formula again. That would be -t, so sorry, -b, -9 plus minus b squared minus 4ac divided by 2a. Okay, I'm going to skip some steps. That's -9 plus minus 81. Actually, I'm not skipping any steps. 81 minus 848. Minus 48 is 33. Divided by -4. This time, actually, because root 33 is less than 6, so both plus minus will give me a positive answer. So actually, we'll need to get both answers. So -9 minus root 33 divided by, -9. I'll do plus first actually. Plus root 33 divided by -4. This was 0.8 seconds. And the other one would be -9 minus root 33 and then divided by -4. And this would be 3.7. Okay, so we're looking at what is the time interval? Well, at these two times, the height of the projectile would be at 60, right? We want it to be higher than 60. So if you think about the motion of a projectile, it looks like this, right? Like that. So the first time it reaches 60 is at 0.8 seconds. When it comes down, it's at 3.7 seconds. Therefore, when is it going to be above 60 meters? It's going to be between 0. I probably should write it in words actually. The time interval is in between. Interval is between 0.8 seconds, not meters, 0.8 seconds and 3.7 seconds. Okay, so that will be the answer. Okay, so you need to think about the motion, I suppose, so then you can see it's definitely in between those two times. Okay, so this is above 60 meters. Okay, all right, very last question of Unit 4. How exciting. All right, here it says, the price of manufacturing stereos is given by the formula f of x is equal to 200 minus 0.2x, where x is the number of stereos produced each day. It costs $15,000 per day to operate the factory and $10 for material to produce each stereo. What is the daily revenue? That's part A. Okay, so this is the price of manufacturing, and it costs the price. The price is $15,000 a day, and it costs $10 for material to produce each stereo. Okay, what's the revenue? So what you need to know first is what's the revenue. Okay, revenue, recall, is the price times quantity. Okay, quantity. I think we talked about this in earlier unit or earlier section. So, well, we know the price is given to us, right? The price is 200 minus 0.2x, and the quantity is simply the x. I think there's a typo. You shouldn't say the price of manufacturing stereos. It should just say the price of stereos is given by that formula, okay? So we can actually expand this. Revenue is equal to then 200x minus 0.2x squared, okay? Or if we rewrite it, it's negative 0.2x squared plus 200x. So that is the revenue equation. What is the daily cost? Well, it says it costs $15,000 a day to operate the factory and $10 for materials to produce each stereo. Okay, so the daily cost is going to be $15,000 plus each stereo that we make, it's going to cost $10. So $15,000, that's the fixed cost. It doesn't matter how many we produce each day. We have to spend that much. And each stereo that we make is going to cost us $10. That's why we need to add 10x there. Okay. Finally, we are looking for the interval that produced the profit. So then final, we need to know what the profit equation is. Profit is however much money we get. So revenue minus, well, how much we have to spend to get that amount of money, right? So minus the cost. So revenue, we already have the equation, that is negative 0.2x squared plus 200x minus the cost, which is 15,000 plus 10x. Okay, now we can collect like terms. We get negative 0.2x squared minus 10x, plus 190x, and then minus 15,000. Okay, so now we need to find the interval that produced the profit. Again, profit means means that P is bigger than or equal to 0, right? So we want this to be bigger than 0. Well, if it's equal to 0, it's not a profit. It just break even, right? So it has to be bigger than 0. Okay, so now this is what we're solving for now, okay? So go ahead, I'll let you try it. You probably need to use the quadratic formula, so give it a try. Okay, so here's the work that you should have. Once you use quadratic formula and plug in the numbers into calculator, this is what you should get. X is equal to these two decimal places, two numbers. However, we are producing stereos, okay? So they have to be whole numbers. The question is, do we actually round up, or do we round down, or do we just, look at the decimals and decide? Okay, so now we actually need to think about this. Okay, this is telling us that when we produce 86.89 stereos, we are going to produce profit. That means if we actually produce 86 only, we will not make a profit. So in that case, we actually need to round up. Okay, whereas for 863.1, this is the maximum number of stereos that we can produce to make profit, which means if we increase to 864, we will not produce profit. So in this case, we have to round down, okay? Now, okay, in this case, it just kind of happened to be that's 0.8, so we round up, and that's 0.1, so we round down. That's not the case, okay? So let me just be clear. If that was 89, okay? So let's say if this was 0.1, we still need to round up. This would be we need to produce 87 stereos to make profit. If we make 86, if we produce 86 stereos, we will actually be losing money, okay? Because that's the minimum number of stereos that we need to make a profit. So if we just produce 86, we will lose money, okay? So in that case, you still round up. It does not matter what the decimal point is. Same thing with this. If this was like 0.9, we actually still need to round down because that's the maximum number of stereos that we can make to make profit. So if you produce more than this, so 864, then we're losing money. So it does not matter what this decimal point was, we would need to round it down, okay? So, I mean, it just turned out, it was just happened to be, was 0.1, so that's okay. So to make a profit, we need to produce, between 87 and 863 stereos to make profits. Okay, that is it. Hopefully that was okay. Again, if you need some help, let me know. You can always rewatch the video at a slower pace. That's definitely okay. Yeah, but that's it. The longest chapter of Pre-Calc 11. But we're done. All right. Let me know if you need some help. Good luck.